Thank you so much for joining me for video 2 on tonight's solving addition and subtraction inequalities. And we're going to continue because you were asked to take notes on the subtraction property of equality from the Big Ideas top of page 132, where we are going to now concentrate on solving subtraction inequalities. So ladies and gentlemen, you took some notes, and of course it said when you subtract the same number from each side of an inequality, the inequality remains true. So it's exactly the same as addition. If I add the same number to each side, our inequality remains true. And if now subtracting the same number from each side, the inequality still remains true. Showing you an example numerically would be, well, I have 6. 6 is less than or equal to 9. That is a true statement. If I subtract 7 from both sides, I'm subtracting the same number from each side of the inequality. I have -1 less than or equal to 2. And yes, that is a true statement. Showing it algebraically, again, A is greater than or equal to B. If I subtract C from both sides, oops, C, not 6, C, then A minus C is greater than or equal to B minus C. Again, doesn't matter which inequality symbol we have. Does not matter. If I subtract the same number from both sides, the inequality will remain true. So let's get right to it. Right to it. It's solving and graphing using subtraction. So 14 greater than x plus 8. I want to isolate that variable. I want to subtract 8. That is the inverse, leaving me with x. The inequality is going to remain true because the property of equality says if I subtract that same number 8 from both sides, that my inequality would remain true. Now, I mentioned this briefly in the previous video. I do not like graphing with the variable on the right. So before I even go to graph it, I like to write with the variable on the left. So I'm going to reverse the order, and I'm going to write x is less than 6. That is the same exact thing as saying 6 is greater than x. Notice I flipped the side of each number on the inequality and then flipping the inequality. It was pointing at the 6 the first time. I'm sorry. Rewind. The inequality is pointing at the variable x. And when I rewrote it, the inequality is still pointing at the variable x. Now I can come over here and put my target number 6. One that's greater than is 7. One that's less is 5. I'm going to have an open circle because 6 is not included in the solution set. And now with my variable on the left side, I know that my graph, my arrow of all the numbers that are solutions to this inequality go to the left. And of course, if you wanted, you could conduct a test to verify that our graph is in fact correct. Moving on to example 6, w plus 7 greater than or equal to -10. So my inverse operation is to subtract 7 from both sides of the inequality, and that will tell us that w is greater than or equal to -17. My variable is on the left. We're good to go. My target number, -17. One that's greater is -16. One that's less is -18. I know that my target number is included because it's greater than or equal to. So I have a closed circle on my target number. And with the variable on the left, I can follow my inequality and draw my arrow showing all the numbers in the solution set going to the right of our target number. Our next example, number 7, -7.5. -7.5 is less than or equal to d plus 10. Of course, we are adding 10, so our inverse operation is to subtract 10. And to use properties of inequality and keep that inequality true, I'm going to subtract 10 from both sides. That leaves that -17.5 is less than or equal to d. Well, I don't like that. I don't like that one bit. So I'm going to take my d and put it on the left. And I'm going to reverse the inequality and make it greater than or equal to, and I'm going to put the -17.5 on the other side. And again, when my inequality is pointing at -17.5, it's still pointing at -17.5. So these are the same exact statements. But now with my inequality on the left, I can put my target number, -17.5. -17 is greater, -18 is less. My target number is included, so I'm going to have a closed circle. And again, with my variable on the left, I can follow the inequality and graph my solutions to the right using the arrow. Ladies and gentlemen, we have one last example with subtracting the same number from both sides and solving a subtraction inequality. In this case, x plus 3/4 is less than 1 1/2. So what am I going to do? I'm going to use the inverse operation, and I am going to subtract 3/4. And I'm going to subtract 3/4 from both sides of the inequality. So I have x is less than. I know that when I subtract the same number from both sides of an inequality, my inequality stays true. So now I'm going to take this 1 1/2 and make that 3/2. Turn that into fourths. That's 6/4. 6/4 minus 3/4 is 3/4. My variable's on the left, so my target number, 3/4, goes right in the middle. Well, 1 is greater than 3/4 and 1/2 is less than 3/4. Some of you might put a 0 in there. It doesn't matter as long as your number line is correct. My target number is not included in the solution set, so I'm going to use an open circle. My variable being on the left says my inequality goes to the left, and I am going to graph to the left, showing all the solutions to this inequality. If you don't believe it, conduct the test. Always conduct the test if there's any doubt at all in your mind. Ladies and gentlemen, we have completed video number 2. You have one more quick write to do, so if you would please copy this down. C, we're going to solve a plus 13 is less than 8. You're going to make a graph. You're going to graph it. This video was not that long, and the next video is just as long, if not shorter. So you might come right back, or you might take another break before you come back. Either way, I'm looking forward to seeing you one more time tonight